Hello, dear students. You are welcome to RK Institute. I am Dr. RK Seni, and today I am going to discuss detection and estimation of nitrogen of the organic compound. As you know, it is very important topic for NEET and JEE examination. First, we discuss their method, Duma and Kjeldahl, and then solve some questions. These are the related questions of Duma method and Kjeldahl method. These questions asked from previous examination of JEE and NEET examination. First, we discuss detection of nitrogen in organic compound. Detection of nitrogen, particularly qualitative analysis. Qualitative analysis means how can identify nitrogen present in the compound, likewise their color of the precipitation, smell of the gas, solubility, etc. First, the detection of nitrogen mainly carried out by Lassaigne extract. Lassaigne extract. Its formation. First, we use a ignition tube. Very thin tube present in laboratory. These are known as ignition tube. On heating, its mouth is closed. Ignition tube. Then we added small pieces of sodium. Sodium kept under kerosene in laboratory, and it is a soft metal. Therefore, small pieces are easily cut by knife, dry with filter paper, and then put in the ignition tube. And then add organic compound. This ignition tube is strongly heated in Bunsen flame or in spirit lamp. Strongly heated. It is Bunsen flame. This ignition tube, with help of clip stand, is strongly heated. These are the clip stand and heated. Red heat. And then after red heating of the ignition tube, it put down into the another test tube which contains distilled water. Distilled water is the pure form of water in which any type of ions are not there. For example, in tap water, this contain chloride, fluoride, nitrate, sulfate, etc. After putting of the ignition tube in distilled water, it breaks down and on further heating and then cooling at room temperature. And cooling at room temperature or kept at room temperature. Then it keep at room temperature. Then their residue settle down and filtrate in above. And this test tube, their filtrate taken in another test tube. And this filtrate is known as Lassaigne extract and residue left in this test tube. Now we detect chemical change if nitrogen is there in organic compound. In organic compound contain carbon. If nitrogen is there and we added sodium and on strongly heating, then they change into sodium cyanide. If nitrogen is there, then organic compound with sodium piece change into sodium cyanide. Now we taken Lassaigne extract in another test tube and added fresh solution of ferrous sulfate. Fresh, it is greenish in color. Therefore, fresh solution of ferrous sulfate and formation of a complex. Check chemistry also. In FeSO4, the ion is ferrous, and we know that in Lassaigne extract, cyanide is a ligand, and we know that cyanide make complex with Fe+2, and this complex is FeCN6. Highest coordination number of iron is 6. Oxidation state of iron is +2 and cyanide is -1. Therefore, this complex carry -4 charge. Or write a balance reaction. We write Na4 FeCN6. It is yellowish in color. First, it is yellowish in color. Then further, we added ferric chloride in presence of HCl. Ferric chloride in presence of HCl. In presence of HCl, it make another complex in which Fe+3 and this anion carry -4. Then we write formula Fe4 FeCN6. FeCN6 whole thrice. This is the valency of ferric and the valency of this complex ion. Deep blue, and it is known as Prussian blue. Prussian blue, commonly known as Prussian blue, or is known as Ferri +3 ferrocyanide. Ferrocyanide. It is the detection of nitrogen by Lassaigne extract. When FeCl3 added in this yellowish solution, then deep blue coloration is observed. Deep blue coloration is observed. Like as this. Deep blue coloration or precipitation. Deep blue coloration or precipitation. It is known as Prussian blue. Prussian blue. It is the test of nitrogen. If in addition to nitrogen, if sulfur is also there, if addition to nitrogen is sulfur is also there, then organic compound contain carbon. Then organic compound contain carbon, nitrogen, sulfur, and sodium metal. Then they make sodium thiocyanate. And when addition of ferric chloride in this solution, blood red coloration is there. Blood red. Blood red coloration, not precipitation. Blood red coloration is there. Blood red coloration is there. This is the test of nitrogen and sulfur both. This is the test of nitrogen and sulfur both. Blood red coloration, not precipitation. Whole solution change into blood red. Blood red. Blood red. This is the test of both nitrogen as well as sulfur present in organic compound. Organic compound contain carbon. If nitrogen and sulfur both are there and we added sodium piece during the formation of Lassaigne extract, then blood coloration, blood red coloration. These are the qualitative estimation of nitrogen. Now we discuss quantitative estimation. Now we discuss quantitative estimation of nitrogen. Two methods for their quantitative estimation. Quantitative estimation of nitrogen in the organic compound. In the organic compound. namely two methods, Duma method and Kjeldahl method. First, we discuss Duma method and their concept: organic compound heated with cupric oxide, strongly heated with cupric oxide. Their carbon change into CO2. Their carbon, organic compound contain carbon. Their carbon change into CO2. Their hydrogen change into H2O. Their sulfur, if organic compound contains sulfur, change into SO2. Their sulfur change into SO2. And their nitrogen, if nitrogen is there, it change into nitrogen gas. Quantitatively change into nitrogen gas, because nitrogen of organic compound react with cupric oxide, then it make oxides of nitrogen, different type of oxides of nitrogen, like as nitrous oxide, laughing gas, nitric oxide, N2O3, etc. And these oxides are further react with copper at high temperature, then they make copper oxide and evolve nitrogen gas. Now we then this solution, then this gaseous mixture pass through the solution of KOH. This solution pass through the this gaseous mixture pass through the solution of KOH. Then when gaseous mixture pass through the solution of KOH, then acidic gases. Measuring cylinder contain QH and these gases pass in this solution. Then acidic gases are absorbed by the QH and only nitrogen gas collected on measuring cylinder. Nitrogen gas collected on measuring cylinder. This is the volume of nitrogen gas. It is the volume of N2 gas measured by measuring cylinder. Now we use gaseous state equation P1 V1 T1 equals to P2 V2 and T2. These are the condition of STP or NTP. We convert experimental volume of N2 gas by at STP by this equation. Here important point, it is the volume, experimental volume of N2. V1 is the experimental volume of N2. P2 is the experimental pressure of N2 gas. In some cases, N2 gas contain moisture. Therefore, total pressure by the subtraction of the aqueous tension of H2O. Then we find total pressure of dry N2 gas, and the temperature is experimental, and then convert STP. Pressure is 760 mmHg. We find volume at STP, and the temperature is 273 Kelvin. And we find volume of N2 gas at STP or NTP. This volume divided by 2 to ml. This volume divided by 2 to 44400, then we make their mole. Their mole multiplied by mass of the nitrogen, then that is the amount of nitrogen in organic compound. This amount comes from X gram of organic compound taken under investigation. Taken under estimation, X gram of organic compound. This nitrogen comes from X gram. Therefore, the percentage of nitrogen in this organic compound is percentage of nitrogen. First we find volume of N2 gas at STP by the calculation. And this volume can change into mole. This volume change into mole. Mole multiplied by the molar mass of N2. Then it is the amount of nitrogen gas. It is the amount of nitrogen gas comes from organic X amount of organic compound. Therefore, percentage divided by X into 100. Percentage of nitrogen. 2-3 questions explained in this method. For example, first, we also explain another qualitative and quantitative analysis of nitrogen by Kjeldahl method. By Kjeldahl method. In this method, organic compound is strongly heated with concentrated H2SO4 in presence of copper sulfate or mercury sulfate as a catalyst. Copper sulfate or mercury sulfate as a catalyst. Strongly heating. This process is known as digestion. Digestion means all organic compound, their nitrogen, carbon, etc. are digested and organic compound contain nitrogen change into ammonia. Ammonia is basic and H2SO4 acid, therefore whole nitrogen quantitatively change into ammonium sulfate. On treating ammonium sulfate by a base, then they evolve ammonia gas. Qualitatively ammonia gas, when passed with Nessler reagent, then it gives brown precipitate. Nessler reagent with alkaline solution of K2HgI4. It gives brown PPT with ammonia gas or all ammonium salt. Give brown precipitate. Give brown PPT. This brown PPT is known as iodide of Millen's base. Chemically, it is a complex species. Brown precipitate. Like as this. It gives brown PPT. All ammonium salt and ammonia gas give this test. All ammonium salt and ammonia give brown precipitate with Nessler reagent. What do you mean by Nessler reagent? Alkaline solution of K2HgI4 is known as Nessler reagent. It is the qualitative analysis of ammonia. And in quantitative estimation, this ammonia treated with standard solution of acid. In quantitative estimation, this ammonia pass through the standard solution of acid, and then by the use of law of equivalence, we find percentage of nitrogen in organic compound by quantitative analysis of nitrogen. We use law of equivalence. Gram equivalent of ammonia equals to gram equivalent of acid. Standard acid. Standard means their normality, a molarity or standard volume is find. And therefore we find weight of ammonia, because gram equivalent equals to weight upon equivalent weight of ammonia is 17, and the gram equivalent of acid is NV upon 1000. Therefore the weight of ammonia is NV of acid into 17 upon 1000. This weight of ammonia in organic compound, we know that 14 gram nitrogen present in 17 gram of ammonia. Therefore total amount of nitrogen in this organic compound, this nitrogen, now it is the weight of nitrogen comes from organic compound, X gram of organic compound taken under investigation. Therefore the percentage of nitrogen divided by X into 100. It is the percentage of nitrogen in organic compound. Another further change. First, we evolve ammonia gas. This ammonia gas treated with standard solution of acid. Standard means their normality, molarity given, and their volume is calculated by the titration method. Now, by the use of law of equivalence, we find weight of ammonia. We know that 14 gram nitrogen present in 1 mole of ammonia. Therefore, this amount of nitrogen present in total ammonia. This nitrogen comes from X gram of organic compound. Therefore, the percentage of nitrogen in organic compound calculated with this. One limitation is also remember for this method. Kjeldahl method limitation. Limitation of Kjeldahl method. Is compound which contain azo group, contain azoxy group, contain nitro group, contain nitroso group, or nitrogen in aromatic ring like as pyridine, like as in quinoline are not give this test because this is the quinoline. Quinoline, it is the pyridine, are not under the estimation of Kjeldahl method because their complete nitrogen is not changed into the ammonia. It is the limitation. Now we discuss some questions comes from Duma method and Kjeldahl method in JEE as well as in NEET examination. Question number first. Question first. This is the very simple question. Monomer X involving synthesis of nylon 6,6 give positive carbylamine test. It means primary amine present in this compound. Carbylamine test is important test of primary amine. KOH and chloroform give offensive smell. If 10 moles of this X analyzed using Duma method, then amount in gram of nitrogen gas evolved is first, we identify monomer of nylon 6,6. Nylon 6,6 is a copolymer of adipic acid and hexamethylene diamine. Hexamethylene CH2, CH2, CH2. It is one monomer 1, 2, 3, 4, 5, 6. Hexamethylene diamine and adipic acid. They make nylon 6,6. In this compound give carbylamine test and it contains 1 mole of this compound contain 1 mole of N2 gas, or we can say 2 moles of nitrogen atom. Therefore, 1 mole of this compound evolve 1 mole of N2 gas. Quantitatively, 1 mole of this compound give 1 mole of N2 gas. 10 moles of this compound gives 10 mole of N2 gas. Therefore, their molar mass, therefore their amount is 280 gram. Very easy question. And in this question asked in JEE Advanced 25 last year. Question next. On passing gas X through the Nessler reagent, a brown precipitate is obtained. That gas is. This question is also asked in JEE Main in 2024. This gas is ammonia. Question next. Very simple question, but theoretical question also. Question third. In Duma method, estimation nitrogen 0.1 gram of organic compound with 30 ml nitrogen collected over the 300 Kelvin and 7.5 mm at the pressure. The percentage of nitrogen in this compound, aqueous tension at 300 Kelvin is this. It means it is the pressure of moisture. Therefore, the pressure of nitrogen gas is 715 minus this. P1 V1 upon T1 equals to P2 V2 upon T2. These are the experimental conditions. We find volume of N2 gas at STP. Pressure of gas is 715 minus 15 because aqueous tension means moist. The pressure of moisture is also. Therefore, it is P1 700 volume given 30 ml, temperature 300 Kelvin. It is the experimental condition. Pressure at STP is 1 bar, means 760. We find volume of N2 gas at STP and the temperature at STP is 273. Therefore, the volume of STP of gas, STP or NTP, divided by 2200. Therefore, it is the moles of N2 gas multiplied by 28. It is the weight of N2 gas. This weight comes from 0.1 gram of organic compound. This weight comes from 1 mole of organic compound and hence percentage of nitrogen in this compound. Percentage of nitrogen in this compound. V2, putting the value of V2, where V2 equals to 700. V2 equals to 700 into 30 into 273 divided by 300 into 760, and on solve we find amount of compound in this method. The question next, Duma method of the nitrogen estimation, 0.14 gram organic compound gave 22 ml of nitrogen at STP. Direct given STP, then percentage of this. The volume of nitrogen get STP divided by 22400. It is the moles of nitrogen. It is the amount of nitrogen. This amount comes from 0.14 gram of organic compound. Therefore, the percentage of nitrogen in this compound, calculate by this. And your answer is 20%. Question 4. Question next, 5th. Ammonia evolved from 0.7 gram sample of organic compound utilized by 300 ml of 0.1 m H2SO4 in Kjeldahl method for the estimation of nitrogen present in soil sample. The percentage of nitrogen in this sample. First, nitrogen. We find according to law of equivalence, gram equivalent of ammonia equals to gram equivalent of H2SO4. We know that gram equivalent equals to weight of ammonia upon their equivalent weight equals to N into V. N, 1 N solution of H2SO4, their volume is 300 ml by 1000. Therefore, the weight of ammonia is 1 into 300 into 17 upon this from organic compound. We know that 17 gram ammonia contain 14 gram of nitrogen. Therefore, total amount of nitrogen in this sample, and this nitrogen comes from 7 gram of the compound. Therefore, percentage of nitrogen. Therefore, percentage of nitrogen equals to, first we find amount of ammonia by the law of equivalence. We find weight of ammonia by the law of equivalence. Very simple. Then we know that 1 mole of ammonia contain 14 gram of nitrogen. 1 gram contain 14 by 17. Therefore, this amount of ammonia contain this amount of nitrogen. This nitrogen comes from given weight, taken weight of organic compound. For example, in this question, we taken 7 gram and hence percentage multiplied by 100. Therefore, 60% of nitrogen present in the given sample. Question next. Which pair of which compound their nitrogen cannot be estimated by Kjeldahl method? Nitrobenzene. First compound is nitrobenzene. Nitroso, azo, pyridine, quinolene, जिनकी nitrogen present in the aromatic ring are not undergo this test. Nitrobenzene, quinolene, both are not give this test. Azobenzene, hydrazine. Very important, hydrazine, because one time asked in JEE, hydrazine is not organic compound. Hydrazine is not organic compound, and this method is suitable for organic compound. Therefore, hydrazine is all their nitrogen is not detected or estimated by Kjeldahl method. Pyridine, azoxybenzene, both are absent. Therefore, all of these compounds are not suitable for the detection of their nitrogen by Kjeldahl method. Question 7. Question 7. For estimation This question also asked in JEE examination, main examination in 2014. In this question, evolved nitrogen estimation of 1.4 gram organic compound, Kjeldahl method, ammonia absorbed by 60 ml of 0.1 m sulfuric acid, and then unreacted acid required 20 ml of 0.1 m sodium hydroxide for complete neutralization. The percentage, it means gram equivalent of ammonia equals to gram equivalent of H2SO4. When excess amount of H2SO4 react with NaOH, therefore the actual amount of, we find actual amount of H2SO4, given amount of H2SO4, and their excess means excess amount of acid titrate with NaOH. Therefore this amount, therefore their difference is used for the ammonia. First 0.1 m multiplied by 2, because their X factor is 2, into 60 divided by 1000 H2SO4 20 ml, 0.1 m X factor 1, 20 ml divided by 1000, and hence the H2SO4 12 or 10, 20. Therefore the milliequivalent equivalent of H2SO4 used for this titration is 10 by 1000, because 20 minus 2 upon 1000, and hence this. And now we find weight of ammonia. Weight of ammonia, this is the weight of ammonia. This weight of ammonia, we know that 14 gram nitrogen present in 1 mole of ammonia. Therefore this is the weight of nitrogen gas, and this weight of nitrogen comes from 1.7 gram of organic compound, 1.7 gram of organic compound. Therefore their percentage of nitrogen in this sample. In this question we find actual milliequivalent, actual gram equivalent of H2SO4 used up for ammonia. Therefore the excess amount of H2SO4 titrate with NaOH, their difference is used for the ammonia, because first H2SO4 and NaOH titrate, by which we find consumed volume of H2SO4 ammonia, and then check percentage of nitrogen, 10% of nitrogen present in this ammonia. ओके दोस्तों, तो ये आपके पास में कुछ क्वेश्चन थे डूमा मेथड और जालदाल मेथड के, और बेसिक कंसेप्ट थे अबाउट द क्वालिटेटिव एनालिसिस एंड क्वांटिटेटिव एनालिसिस ऑफ